So we're negative here, we're positive here. We change sign right between these two intervals at negative 20. So there's a sign change here. And then we go from positive to negative at 5, right? Okay? So there's the sign change. And we go from negative to positive at 22. So, well, those are the zeros of the k of x function, aren't they? So the sign changes occur at the zeros. Okay? Now, it turns out that signs don't have to change at the zeros, but if they do, it has to be at a zero. Okay, so there's a rule. I hope I've got a clean board behind this. Yeah. Okay, the rule is box around it means it's important. Sign changes for polynomials occur only at zeros. Now this doesn't say they necessarily occur at zeros, but it says if they occur, got to be at zeros. So I say if they occur it's got to be at the zeros. Today the 5th?
Yes.
Yeah. Okay. Make sense?
Mm-hmm.
So if I know the zeros, so all the zeros are shown here. Okay? Could the polynomial have a graph that looks like this? Okay? All the zeros are shown. This one, this one, this one, this one, and this one. Then this can't be the graph of a polynomial with those zeros. Okay? I needed all of whose zeros are shown. Why not?
Because of that one right there.
because it goes through the axis here. That would have to be a 0, right? Okay? So this is not one of the zeros. That would be a 0, right? And then you'd have another sneaky one over here. Okay? So the graph of a polynomial can only be 0 at one of the zeros. Okay? So, if these are zeros, how about this graph? Is it okay? Okay? Now notice that there's a 0 here where it does touch 0. At least that's the way I intended to show it. Okay, it does touch 0 here, but it doesn't go through. It doesn't change sign there, does it?
No.
Now just a little teaser here. What's the shape of this graph in the region very close to that 0? It's kind of a parabola, isn't it?
Yeah.
Okay? And what's the shape of the graph as it goes through here, very close to it? It's pretty much linear. It's got a little, it's got to have some curvature, but if you look close enough, you can't even see the curvature. It's going to look like a straight line, right? So close to this, or this 0, the graph looks like a straight line, just if you look at it in a very small window, okay? If you look at this one in a very small window, it looks like a parabola. And of course, a parabola can sit on the x-axis, can't it, without going through. A straight line can't have a 0 without going through. Okay? And you could even have one that looks like this. What's happening here? What's that look like?
A cube.
Looks like your x cubed function. One of the many reasons, the first thing I ask you to do is learn how to draw those graphs, right? So you recognize them? Okay? And understand how they occur so we can understand the graphs of polynomials. Okay. Look for your assignment.